Thank you for introduction. And thank you very much for introduction, giving me and thank you very much for giving me such an opportunity to give interesting workshop talk, such a very interesting workshop. This is I would like to talk on rapidly rotating geometry. I would like to talk on rapidly rotating University, Japan. I am Kenichi Nakao from Osaka City University, studying in collaboration with these members. Subject is studying in collaboration with these members. Including rapidly rotating geometry is rapidly rotating geometry is current space. Maybe current space very well. You know, maybe you know very well. You know. Anyway, current space-time, as you know, current space-time is vacuum stationary, as you know, current space-time is vacuum stationary solution of Einstein equation. Solution in buoyant quick coordinate equation. The line in buoyant quick coordinate, the line element. And in buoyant quick coordinate, the line element is given like this, and important parameters are mass of m and a curve parameter, which is the angular momentum per unit mass. So, as you know, in the case that S square curve parameter square of curve parameter is less than or equal to the line parameter square of mass parameter. Important there is a horizon parameter and mass m and a curve parameter square which is the angular momentum. There is no horizon, so this solution describes the negative. So, as you know, usually black hole solution. The black hole case is S square. That is curve parameter square of curve parameter is less than or equal to overspinning curve geometry. Is also very interesting. So there is a horizon in this talk, and we focus on overspinning case. S square is larger than m square. There is no horizon, so this is described as negative. It is very important, but very difficult. Usually, black hole solution, black hole cases from the negative singularity. But so in this talk, the overspinning curve geometry is also very interesting of the singularity. So here in this talk, we focus on the overspinning case. S square is larger than m square. So, and anyway, I would like to show one example why the overspinning curve geometry is interesting from the negative singularity process. So in this subject was studied by the definition of the singularity. By this just at the singularity, and we assume the curve parameter is a little bit larger than the critical value n. Anyway, I would like to show one example why the overspinning two-part geometry is falling into the naked singularity like this. This subject was studied by collision occur by this at r equal to m. By this member. This is very important. Far from the singularity. The curve parameter is a little bit larger than the critical value particles. And in such a situation, one is going away to infinity, and two other one is falling into the naked singularity. In this case, the energy assumed the collision occur going away to infinity can be very large. This is not far from the singularity parameter. Then, small one, we assume that the energy particles are generated here. one is going away to infinity, by contrast, is falling energy of falling particle. In this case, the energy of particle going away to infinity can be very large, and please note that energy of ingoing particle is very small, indefinite, so can be indefinitely energy of outgoing particle. As a result, through this horizontal process, the energy of infalling particle can be negative, can be extracted. M is inside the L and the energy of ingoing particle is the limit indefinite, can be indefinitely the efficiency of the energy. As a result, through this horizontal process, the energy upper bound of singularity. So, if there is the energy of such a geometry in our universe, extracted, ultra high energy, high rate can be produced through such a process, like this, in the limit of epsilon goes. So, anyway, such a efficiency of the energy extraction. Next important task we should do is to study the stability of such a interesting space. So, if there is there are several studies geometry in our universe. This ultra high energy cosmic ray can be produced through such a process. Here we focus on two studies given by Cardo. So anyway, such a they study next important task perturbation of focus spinning to study stability of such an interesting space, especially focus on quasi-normal mode. There are several studies NASA variable of perturbation already been studied, and here we focus on the two studies given by Carlton's group. At the time of dependence, they studied perturbation of focus spinning space-time, which is very difficult to read, especially focus on quasi-normal mode. In order to obtain the solution, master variable perturbation equation, which is obtained by linearization of Einstein equations, we need to impose the boundary condition at the naked singularity to fit this. But the time dependence, they did exponential minus I. They did not impose the boundary condition at the naked singularity. They assumed this boundary condition. Impose the boundary condition in order to obtain the solution of the perturbation equation, the wave equation, constant are obtained by linearization of Einstein equations. We need to impose the boundary condition at the naked singularity boundary condition, but they absorbing boundary condition. They did then assuming they did not impose the boundary condition at the naked singularity, they assumed in order to obtain the equation, impose the boundary condition on the numerical addition, they spare numerically with the constant perturbation equation, the result. And they assume two boundary conditions. The resulting boundary condition and the imaginary part of the angular frequency. Then assuming the this means that this space-time is unstable. That's all. Here, numerical addition they solved numerically. Let me show you the table. The result, this table is shown is given in the second paper. Imaginary part of the angular frequency omega is positive. This means that this space-time is unstable. The red underbar. That's all. No. They obtain the angular frequency show you the table, various parameters. This table is boundary is given in the second paper of Carlos's group. Various variety of boundary sphere. Let's focus on these numbers. With this red left-hand side one is the real part. They obtain the right-hand side one angular frequency, and the imaginary part for various parameters is decreasing as the boundary, the radius. So imaginary part of the frequency is increasing function of boundary sphere. So and this is the left-hand side one is the real part, and anyway, in the limit of the imaginary part, and the imaginary part approaching to m decreasing. Imaginary part of the angular frequency. So imaginary part of the frequency is zero. Increasing function of wave. This means that this is very difficult to see. Yes, this anyway does not depend on the radius and the boundary condition. Approaching to m. Imaginary part of the angular frequency, the imaginary part of the angular approach is zero. So this means that this tendency is unchanged. If we change the radius of the boundary, does not depend on the radius and the boundary condition. Near extremal overspinning curve has very long lifetime, becomes more than zero imaginary part of the angular frequency decreasing. So here it should be noted that we are interested in the case of the radius of the boundary surface sphere. Anyway, case of this. Parameter extremal overspinning curve has very long critical value. Okay. So in this case, an interesting overspinning curve geometry here has a very long lifetime. Should be noted that we are interested in this case of this geometry is produced. Curve parameter is a little bit larger than the critical value. So in this case, interesting next question. The interesting such a curve geometry interesting has a very long lifetime. So effectively, this space form in our universe stable. In order to obtain this geometry to this question, we consider produced in our universe. This problem: how small is an overspinning body? So next question. This is very non-trivial. Can such a interesting overspinning curve geometry form in our universe? In order to obtain, let's consider suggestion to this question. We consider gravity. M1 is mass problem. How small is an overspinning body? The other, the mass of the other, this is very non-trivial subject. Energy very simple, but very non-trivial. In order to get the intuition, let's consider two relativity particles without any interaction for gravity. In this one is mass, and E1 is energy. The other, the mass of the other, another particle is M2, and energy is M2. Then, how to finish this? Can I change the file? PDF, I would like to use the PDF file. No? And this is here. No. I have. So fine. Everything already. So, これはhow to punish this? そうです。This is an art. I have video file everything already. Okay. The angular momentum of this system, total angular momentum of this system is given by this in the center of mass plane. Here B is the impact parameter, mu is the relativistic reduced mass, and V is the relative velocity of these particles. And the curve parameter of this system is given by this, where M is given by this, the total mass of this system. The angular momentum of this system, total angular momentum of this system is caused by overspinning center of mass plane. Then this overspinning impact parameter leads to the lower bound on the impact parameter, relative velocity of the lower bound, and the curve parameter radius of this system is given by this, where M is given by this. This result suggests that no overspinning of very compact body forms in the universe. Let's pass Brown suppose in order that the system is smaller than the gravitational radius, relative to the lower bound on the impact parameter B, like this, speed of light, lower bound is the gravitational radius of this system, some energy violation, dominant energy condition. This result suggests that no overspinning of very compact body forms. In the case of the Newtonian we can, in order that the system is smaller than the gravitational radius, relative velocity V should be larger than 2 times the speed of light of the relative causality violation or some energy violation. Dominant theory, we do not take into account the gravity, so we should. Next, in the case of the Newtonian to study this the system with gravity values, so there is no lower bound and here we consider the following is the framework of the relative principle. Here a snapshot of this analysis there we do not take into account the gravity, so we should. Next, the inside of the shell is vacuum. Study this side is also the system, and the snapshot means the initial data. We will not consider dynamics of the shell following system. Anyway, we assume that the inside of the shell is the regular curved space. This is the shell. And the outside is the overspinning curved space. Inside of the shell is vacuum, and the outside is also vacuum. And the snapshot means the initial data. We assume that shell is located on we will not consider dynamics because capital R which is constant. Anyway, we assume with the inside of the shell is the regular curved space is continuous, even on the outside, but is the overspinning curved space, like a high-pass surface, the initial data. Some components may be discontinuous, and we assume that shell this located is very too strong. Buoyant with coordinates, cannot be continuous, but finite. And furthermore, we assume that three-dimensional metric space is continuous even on the shell. But the three curvature of the space like a high-pass surface, initial data, Anyway, some components may be discontinued. Just because this assumption is the momentum constraint and Hamiltonian constraint in curvature cannot be continued. Three-dimensional metric and X-ray curvature. This is detailed how to set up we obtain the geometrical quantities. Anyway, under we just consideration we solve junction condition, momentum constraint and Hamiltonian constraint and know what kind of matter three-dimensional metric and X-ray curvature and first order derivative of the metric. Then we obtain the geometrical quantities. This implies that some matter, singular matter, which is on the shell, considered the specialized junction condition. Through this junction condition, we can know what kind of matter is confined in the shell. Anyway, since the X-ray curvature and first order derivative of the metric, the stress energy tensor are discontinuous at the shell. On the shell. This implies that the some variable singular matter is on the shell, and that the surface energy tensor J is the angular momentum density of the Israel's junction condition. And by changing anyway basis vectors, we obtain the diagonalized form. We obtain we investigate whether matter on the shell. Investigate whether the reasonable variables are satisfied by this surface energy density, and J is the angular momentum condition, strong energy condition, and by changing the basis vectors, we obtain the diagonalized form. Then we investigate whether we investigate whether the reasonable energy conditions are satisfied by equation of state that does not conflict with reasonable energy condition, weak energy condition, strong energy condition, and energy quality. The surface energy density of the shell is larger than or equal to the numerical results. Square root of 2 times the absolute value of the angular momentum density. And sufficient condition for the existence of condition satisfied that does not conflict with reasonable energy condition. Position radius of the shell. With respect to the surface energy density of the shell, and the answer larger than or equal to yes. Square root of 2 times the absolute value of the angular momentum density, capital R. The energy condition can be satisfied. This condition satisfied for any positive R is the condition. Position radius of the shell, radially moving with respect to the Boyer liquid coordinate. And the answer is yes. So this numerical result implies that any at least very compact overspinning object can transient energy condition can be satisfied without violating the energy condition. So if such a compact object is necessary, if it is radially moved in a reverse high efficiency original Penrose process may occur around it. This numerical result implies overspinning geometries very compact overspinning object, for example, can transiently exist without violating the energy condition. So, if such a compact object, in order that such a compact rapidly rotating compact object forms, maybe some implosion processes may occur around processes are necessary. We may find overspinning implosion processes mean not gravitational collapse. but the gravitationally unbound inward motion of very large kinetic energy. Usually we consider in order that such a compact rapidly rotating some gravitational bound object may be some implosion process and form processes are necessary. This is usual. Implosion processes mean not gravitational collapse. So the gravitationally unbound inward motion of very large kinetic energy occurs. Usually we consider cosmological situation. Often considered astrophysical situation. We know some gravitational bound object, for example, supernova or maybe gamma ray black hole. They are maybe explosions. But so the question we not consider implosion in astrophysical or implosion occur in astrophysical or cosmological situation. Some suggestion we consider usually we know explosion usual response, for example, supernova or maybe gamma ray burst. Simple, they are maybe explosion. Shell 1 and shell 2. Usually we do not consider tangential pressure due to the astrophysical or centrifugal force of particles. In order to get some suggestions, tangential pressure, each shell is oscillating, spherical shell, and occasionally closed particles counter-rotating this figure. The bottom is the radius of the shell, and the horizontal 1 and shell 2. And the blue one is shell has a tangential pressure due to the blue one like centrifugal force of this, and the red one oscillates like this. Due to the both tangential pressure, but each shell is oscillating at the crossing and occasionally crosses. The energy exchange occurs. This static energy exchange occurs horizontal is the time case, and blue one is a shell 2, red one is a shell 1, blue one like but in relative case, the efficiency of energy exchange is very high. Bounded. So, for example, at the crossing, the energy exchange occurs. And this such energy exchange occurs even in Newtonian case. The shell 1 and shell 2 cross each other like this point. But in relative case, the efficiency of energy exchange is very high. And then, so gravitationally unbound implosion occurs. The energy of the shell 1 is satisfies this condition. This is a closer gravitationally unbound kinetic energy dominant collapse. Shell 1 and shell 2 cross each other at this point. But at this point, the highly efficient energy exchange occurs. From this example, gravitationally unbound implosion shows the possibility that the energy of the shell 1 even in astrophysical situation this condition through gravitationally unbound kinetic energy dominant implosion can occur, collapse. But so this is just a possibility. So in our universe, our study there is a shows the possibility that from this example, compact overspinning that this example shows the possibility that even in astrophysical situation, through some energy exchanging process, implosion can occur. But this is just a possibility. So in our universe, our study shows the possibility that the very compact overspinning objects form in our universe. Maybe. It depends on the. Yes. Yes. Comments, remarks in the form of consideration earlier. Omega I going
maybe.
zero.
It depends on the.
Smaller and smaller. Means in that case.
Yes. Yes.
Yeah, it means that you can have comments with not infinite like but arbitrarily large.
Yes.
Like your consideration earlier.
You are right.
Omega I
Superspinner
going
can be
zero.
overspinning
As epsilon smaller and smaller.
Yeah. Can have
Means
arbitrarily
in that case.
large lifetime.
Yeah, I didn't mean it's just curved. Yeah, it means that you can have superspinors with not infinite life, but arbitrarily large
Yes.
lifetime. Is that right?
Yes. You are right. Superspinner can be overspinning curve geometry. Can have arbitrarily large lifetime.
Yeah, I didn't mean superspinor. Yeah, it's just curved naked single.
Yes.
Yeah, okay. Thank you very much.